Hi guys, today we will be starting to working on TinkerCAD. This is the seventh project that we'll be working on. So in this project, what you're going to do is you're going to literally try to build a small mini piano by using the push buttons. And this is slightly longer project, so that's the reason I'm recording it a little earlier than our class time. And what I want you guys to do is I want you guys to follow the same steps of whatever I'm doing right now. Okay, before that, let me show you my screen and let me show you how our project is going to look like. So at this point, you will be able to see my screen. And by the end of today's class, you will be making a project something which looks like this. This looks very big project rather than what we actually did. But if you see, it's just how you connect one push button and you're going to repeat this for 7 times. And for each of this push button, you guys know piano, right? Like when you press a key, sound comes. The same thing. When you press a button, a certain frequency plays, and this buzzer is going to act as your speaker. So how are we going to connect this is something that you're going to learn in today's class. Okay, it's very simple, quite easy. But before that, I want you guys to start taking a little bit of notes. Okay, so take down the date and take down the heading as 2.7 mini piano. So things that we need are we need 7 push buttons, one buzzer, which is acting as a speaker. So each push button is corresponding to one frequency, one different frequency. And each frequency is going to give you a note. So you can pick from 1 to 128. There are 128 notes, right? C3, C4, D, C, D, E, F, G, A, B. And then each one has 1, 2, 3, 4. So most probably we'll be working with C4, D4, E4, F major, and all of these music notations that you might have learned in your music class, right? So we have 7 push buttons, we have one buzzer. So for both of them, we need 8 resistors of 1 kilo ohm value. Okay, so these are a couple of things that these are some of the things that you would need, along with a breadboard and an Arduino kit and cables, of course. So what we are doing is we are creating 7 push buttons. We are using 7 push buttons, and each push button has a different frequency, and each frequency is a notation. It's nothing but a music note. So whenever you click this particular button or whenever you press this button, this buzzer will read the frequency and will make some sound, and that sound is nothing but a notation, a music notation. And I'll show you the circuit diagram right now. Circuit diagram is very easy. All you have to do is just follow one thing and keep making the same thing over and over. So if you make one particular button successful, I'm pretty sure that you can easily do all the other buttons as well, but you have to do it very slowly and do it with me. So first thing what you would need is you would need to create a new circuit. When you're creating a new circuit, there are certain things that you need to make sure of. I think this is better. So the first thing, please do rename it as 2.7 mini piano underscore I'm writing my name, but please, guys, you need to write your name. Okay. So the first thing that we would need is an Arduino board. And when I pull this Arduino board, one thing that I'm making sure is if you see that the pins are horizontal right now, but I don't want horizontal, I want them to be vertical. So click on the board and press R to rotate it. This is one way to rotate it, and the other way to rotate it is at the corner leftmost corner under the logo, you see there is an option called rotate. Click that, it automatically rotates. I want this to be in this corner, and I want my breadboard. So get the breadboard and put it over here. Now here, what you're going to do with the breadboard is see the same thing. The pins are vertical, but here the pins are horizontal. So try to make them rotate it and make them vertical. Okay. The next thing that you need to do get is you need to get your speaker. And in our case, we are going to use a piezo buzzer as a speaker. Same thing. If I put my speaker over here, you see how much space it is occupying? It is almost occupying 1/3 of my breadboard. So what I'll do is I'll rotate this where it is inverted. Right now, I'll take this and I'll put it in the cornermost pin or in 29. Remember this? I put it in 29 and I have a reason for this why I put it in 29. So just put it over here. Now, the next step, what you need to do is you need to start getting the connections. So the first connection is you take 5 volts from the breadboard and connect it to the positive terminal. And always my 5 volts is going to be in red color because that is the one that is giving current, right? You see how I connected from 5 volts to the positive and I made it red color. The next important step is take the ground and connect to the ground cable and make this black, right? So the next important thing what I need to do is I need to access this. I need to, control this buzzer. And how do I control this? Either by using analog pins or digital pins. But this because this is a digital piece of instrument, so I'm going to use digital pin 2 to control my buzzer. And if you see that buzzer has two pins. On the left side, it is a negative pin. This one is a negative pin. On the right side, this is a positive pin, right? So I am connecting the digital pin 2 to the positive pin of the buzzer. Remember this, or connect it in the exact same way. Digital pin 2 should be connected to the positive pin of the buzzer. Whenever you move your mouse onto the buzzer's terminals, it is going to show which one is negative, which one is positive. Then I will just make it pink color because it is just carrying a signal. Every negative terminal, you know that you need to have a resistor, and that resistor must be connected to the ground. So I'm going to go and take a resistor and put it over here. But the thing is, I need this resistor also horizontal. I cannot use it when it is vertical. So I'll just take it and see exactly where I'm keeping. I'm keeping where this terminal 2 of my resistor is connected to the negative and terminal 1 is connected to the ground. That way it is a safe circuit, or else your circuit will not work. So what I did, please see this carefully. I took the resistor, I converted it into horizontal way, and once I have it in horizontal way, I made sure that it is connected to the terminal 1. I mean terminal 1 is connected to the ground and terminal 2 is connected to the negative terminal, and the positive terminal has the pink cable which is coming from digital pin 2. Now we'll start keeping the buttons. The push buttons So the push buttons, ideally, right, I need to keep it in a way where terminal 2 is on the right side of the breadboard and terminal 1 is on the left segment of the breadboard. If you see, there is a small division over here, right? I'm going to use this division to put this pin. But when I put it like this is not going to work. So what I need to do is, the most important thing that many students forget is to rotate the digital pin. When you rotate it, it fits perfectly. So to fit this, all you have to do is take a push button and rotate it. Keep it over here. As we discussed, we are going to use 7 different pins for 7 different frequencies to make 7 different sounds. So just put it like this. Let's put one step down. So total 1, 2, 3, 4, 5 I've put. I'm going to take 2 more. 6 and final one 7. So each push button has a different frequency, and each frequency is nothing but each music note. Over here, there are 2 important things what you need to do. So the first thing is, the push button needs 5 volts of current, so 5 volts of voltage, right, for it to function. So the whole positive terminal, the reason why I gave over here is, the whole positive line right now, what you're seeing over here, is getting power or is getting voltage from 5 volts from Arduino board. So what I'm going to do is, I'm going to use this to my advantage, because the whole thing has 5 volts. So now all I have to do is just take a cable and connect it over here and make the color red because it's carrying 5 volts. The same thing, all the top terminals. I'm not going to do it anywhere that I want. I'm only going to do it in the same line. You see that? They are in the same line. The same thing. I'm going to go here, connect another line, make it red, make it red. So like this, I need to do it 7 times. Because every push button needs 5 volts, and you know that the complete positive terminal over here is 5 volts. So I'm just taking the connection from here and connecting it to the terminal 1A, such that whenever you press the button, it actually has voltage. The final one. The reason why I'm making red color is just for my color coordination of all my work, so that every single thing that has 5 volts has red color, and every single thing that needs to be grounded is going to be black color. But here, instead of using cable, what I'll be doing is, I'll be directly using a resistor and then connect it to the negative terminal, to terminal 2A. The same way, take a resistor, rotate it, press R, rotate it, or you can press this one as well. So for the next resistor, I'll just click this and then I'll hit rotate. Okay, so take another resistor, rotate, take another resistor, rotate it over here. That's it. Your problem is all, I mean, like, your project is almost done. You have one last step to do once you complete all these resistors, right? Oh, I put it in the wrong hole. When you put it in the wrong hole, it doesn't work. You need to make sure that this resistor is going to the black cable, wherever it is, wherever you're getting the black cable from, because the black cable is coming from the ground, from the Arduino, right? So this whole terminal becomes ground. So now what you're doing, you're connecting a resistor from terminal 2A, because they are all in the same line, to the terminal, to the ground cable, such that your circuit is closed. But whenever you're pressing this push buttons, right, you are taking a signal. And where are you taking the signal? Where are you recording the signal? Whenever you press a push button, you're recording this signal, right? So for you to record this signal, first let me move this a little up. Okay. So now this is the important point. So what you need to do is you need to take a cable from 3, bend it down a little bit, and connect it in between the resistor and the terminal. Okay, keep it in green color. So terminal 3 is connected to this button. Now digital pin 4 must be connected to your next button. So digital pin 5 must be connected to your third button. The same way you're going to connect all of these buttons. So digital pin 6 is going connected to this button. So where am I connecting this? You see this cable is going and sitting right between the terminal 2A and the resistor. This green cables must be between the resistor and terminal 2A. That's when you are actually pressing the button, the signal is being carried out to your Arduino. So based on the signal that you are receiving at your Arduino, you are going to send another signal to your buzzer to make it ring or to make some noise or to make some music. Final one. Every cable. So I started because I could not use digital pin 2 because digital pin 2 is already connected to the piezo buzzer. So I started from 3, and because there are 7 pins, I went till 9. Because there are 7 push buttons, I went till 9. 3 is for push button 1, 4 is for push button 2, 5 is for push button 3, 6 is for push button 4, 7 is for push button 5, 8 is for push button 6, 9 is for push button 7. So that's where I have 7 push buttons, and every push button signal is being sent to one digital pin. So this should be the final code. So final circuit that you're making, right? So now it's all about creating the code. It's all about repeating the code. In the code is the most easiest part. It is not very small, but it is very easy because you just have one block. You just have to create one block for one pin and keep repeating that for all the pins. It is extremely easy, but the only thing is we are going to switch, or we are going to change the frequency. When I start writing the code, you will understand it better. So click on code, you will go to the code, you will already see that there's already pre-built code. I'm going to delete that. Once I delete that, okay, let me go for code and text so you can see the text as well. So the first thing what you need to do is you need to go to control, repeat while. What are you going to repeat is like whenever you press a button, which button? Let us start with digital pin, read digital pin 3. So what is reading digital pin 3? Digital pin 3 is connected to this button, right? Whenever you click the one button, you need to play a sound. You need to play a noise. So that is what we are going to do. But repeat while, go to math, and let's say keep this equal to 1. Instead of 1, now input read digital pin, put it over here, read digital pin 3, because when you are reading digital pin 3, what should I do? Go to output, play speaker. As I told you, our buzzer is going to act like a speaker, but the speaker is connected to pin number 2. You remember? You see this? The positive terminal is connected to a pink cable, and the pink cable is coming from digital pin 2. So that is exactly what I wrote in my code. And I will start with the tone 48. for 0.3 seconds. Now the code is done for one pin. All I have to do is repeat this for all the other pins. That means I have to repeat this code for 7 times. But before doing that, let us test this whether it is working or not. So I'll click the code, go to the start simulation. Okay, so you see that there's a power coming to the Arduino board. That means the simulation has started. So when I click any other button, it is not going to work because we did not create the code. But if we click the first button, it's going to make some noise at a frequency of 48. So that is, you're actually playing the note C4. Okay, I'm going to stop the simulation. I'm going to go to the code part, and all I have to do is I don't have to work on this over and over and over again. So either you can go to control, repeat, write this and complete this all over again. But what I'll do is I'll right click this, and when you right click, you get an option of duplicate. I duplicated this. Now I'll have to exactly put this. See this? Many people put it over here. If you put it over here, it's not going to work. You have to put it right below it. Now we are not dealing with digital pin 3, but we are dealing with digital pin 4. When digital pin repeat while digital pin 4 equal to 1. The reason why I put equal to 1 is, like, whenever you're releasing your finger, that becomes 0. Whenever you're pressing it, it becomes 1. I don't want to use the same tone. Now I want to use tone 50. You see this? Tone 48 is nothing but C4, that is 262 hertz in frequency. Now 50 is D4, that is 294 hertz. So from 48 to 50, there is 32 hertz frequencies difference. The same thing what I'm going to do is I'm going to duplicate this and put it over here and change the digital pin 4 to 5. And then instead of 50, I'll have 52. So now I have finished 3 push buttons. So let us see whether this is working or not. So I'll click on code and go to simulation. Now you will see that because I completed these 3 push buttons, only these 3 are going to work. When I try the 4th one, 5th one, or 6th one, or 7th one, it's not going to work because we did not code them yet. We only coded 1, 2, 3. Excuse me, guys. So now what I'm going to do is I'm going to repeat the process for the rest of the pins. All I have to do is right click, duplicate. So instead of digital pin 5, you just put digital pin 6 and change the value to 54. I'm just increasing it by 2. So I completed all the 4 pins. Now this is going to be the 5th pin, which is connected to digital pin 7. So because our first pin started from 3, 4, 5, 6, 7. But see this 6 and 7, I kept the same frequency. That means you're going to get same tone. But I don't want that. I want a different tone. So I'm going to go to 56. So we have completed total 5 push buttons. Now I'm going to click again, right click, duplicate, put it over here, right below that. And instead of digital pin 7, I'm going to put digital pin 8. This is going to become 58. And finally, I'm going to repeat one last time for my other pin. And it's going to become digital pin 9. And I'm going to end it with 60. That's all. You have to make sure that you have how many pins, how many push buttons you have. You have 7 push buttons. That's the reason in your code also you need to have 7 blocks. You see this? It starts from digital pin 3 and it ends at digital pin 9, giving us 7 blocks of code. Right? I'm just adding the 7 blocks. Each block is representing one push button. And when I start the simulation, Got it? So that is our mini piano project, and I want everybody to try this. And you guys know that I'll be online when you're actually watching this video, right? And whenever you have a doubt, please do ping me on Hangouts or on Google Classroom or on write an email to me. I'll be more than happy to help you. But I want all of you guys to do these projects. From here, all our projects are going to be using some kind of sensors or some kind of push buttons to do some or the other work. So the next 6 projects that we are going to work on are going to be slightly complex, slightly advanced than the first 6 projects. Okay, but yet they're fun to do it, they're challenging, yet you will learn a good deal of mechatronics. So mechatronics is nothing but a combination of mechanical and electronics. So you're going to combine electronics, computer science, and mechanical stuff together to come up with some projects like this. Okay, so in the next class, we will be seeing how we can use a temperature sensor, infrared sensor, and a lot of other stuff, an LCD screen. So there are a lot of other things that we are going to learn. So what I want you guys to do is I want you guys to complete this, and there will be assessment following up, an assignment following up for this project, but I'm not going to give it to you today. That will be in the next class. Okay, so I want all of you guys to complete this project. Make sure that the things where students go wrong, okay, they forget to rotate the push buttons. You just have to put the push button and click R, and they need to be in exactly in the same spot like what I did. You're going to use only the 2 pins of the push buttons, and the resistor values are 1 kilo ohms, and some people forget the PCO buzzer's resistor. So troubleshoot it. You might get an error. Check for the resistor. If it is there, if it is there in the right place. If it is not, move it to the right place. And every push button needs a resistor, and every resistor is going to the negative terminal, and negative terminal is connected to the ground. Positive terminal is 5 volts, that is connected to the positive terminal, as I told you. And push button needs power. So all the 5 volts is directly coming to the push button's terminal 1A. Terminal 2A is connected to the resistor, and the resistor is connected to the ground. But between this resistor and terminal 2A, you're going to take another signal which is in green color, and each push button needs to go for a different pin. So this is what I want all of you guys to do it. And the code is quite simple. So you just have to do one block and repeat that 7 times. And what this block is saying is, if you press the push button, the first push button, that means digital pin 3 is having the signal 1. There are only 2 signals in all of this, right? One is 0, one is 1. That is binary, like either 0. When it is 0, it's not going to work. When it is 1, you're going to play a sound. The tone is 48. And where are you going to play? You're going to play it on the buzzer. And where is the buzzer connected to? Is connected to pin number 2. And for how long do you want to play? For 0.3 seconds. Change it to 1 second. It will be more annoying, more loud. And change it to 0.3 seconds. It will be less loud. The duration will be for a shorter period of time, right? So the same step, you need to repeat it for 7 different push pins. So that's all your project is. Okay, it's a very simple project if you understand it. If not, it seems very complex. But try to, wherever you don't understand, try to pause the video, do the steps, and then go back and try to review it again. If you still don't understand, I'm online, can ping me. Okay, thank you guys. Now I'm going to stop recording.